chemistry practicals, the tests that you carry out can either be classified as preliminary tests or confirmatory tests. Preliminary tests, these are initial tests that are conducted to narrow down the possibilities of what a substance might be. Okay, have you ever seen a practical paper and you look at it and the first step is asking you for the physical appearance of a solid? Or maybe it's asking you to conduct a flame test. Or maybe adding water, see whether the substance is soluble or not. Or maybe heating the substance. These are what are known as preliminary tests. Like they're just narrowing down what the substance could be. Now, after the preliminary tests are done, you move on to the confirmatory tests. Now, the majority of the tests that we carry out are these. So these conclusively identify and confirm the presence of specific ions. Now I'm going to start with the preliminary tests. So I'm going to focus on the observations and inferences you're supposed to make when heating a substance, when adding water to a substance, the physical appearance of the substance, and lastly, the flame test. After this, we are going to move on to the confirmatory tests. So number 1, heating. Now, when substances are heated, either gently or strongly, in most cases, they undergo changes. Some melt, others sublime, others lose water of crystallization. You're supposed to observe carefully the type of change that occurs. Now, change number 1, color changes, of course. Now, when it comes to salts, certain salts have different colors when hydrated and when anhydrous. And the reason for this is because when hydrated, they contain water of crystallization, which they lose on heating, turning anhydrous. So there is a change of color that occurs in certain salts. Now, the most common example, of course, is copper 2 sulfate. This is blue when hydrated, white when anhydrous, since it loses water of crystallization. Other hydrated salts don't change color. You'll find that before and after heating, they're still the same color, but they will still lose their water of crystallization. Now, in most cases, these are the ones that are used in practical tests. So your observation is supposed to be based on the water of crystallization. So what is your observation going to be? You're going to note a colorless liquid being formed on the cooler parts of the boiling tube. Now, you can also state this as such. Either is correct, but if you mention your point as this, a colorless liquid condenses on the cooler part, you miss out on this. And if you miss out on the observation, the inference is not marked. These two are tied. A correct observation will lead to the marking of the inference. Now, why is this statement wrong? The reason why it's wrong is because liquids don't condense. It's only vapor. So just imagine that mistake in terminology can cost you 2 marks. Now, another change that could be expected when substances are heated is a sound that is produced. For example, certain solids produce a sound when heated. Now, an example of this is lead 2 nitrate, as stated before. This produces a cracking sound and a yellow residue is formed. So what is your inference going to be? Lead 2 ions are present. And yes, include the term present. So don't just write lead 2 ions and be done with it. What are you informing us? Are they present or are they absent? Make it clear. Moving on to the third type of observation that has to do with the gases produced. So you find that sometimes when you heat substances strongly, they decompose, leading to the production of a gas. So what are you supposed to do? You're supposed to identify the gas and then identify the ion which was present in the substance and make that your inference. So when it comes to the observation, you're supposed to observe, does the gas have a particular color? Does it have a distinctive odor? What is its effect on moist blue and red litmus paper? Does it have any effect on a burning or glowing wooden splint? Now, in most cases, you'll find that questions that are asking for the observation on gases in terms of litmus papers and wooden splints don't specify that you're supposed to carry out this procedure. You'll find that you simply have a wooden splint and litmus papers on your workstations and you ask yourself, when am I supposed to be using this? You're supposed to be testing the gases with them. Now, our observation, our first gas. Let's say you have a colorless gas that is evolved which extinguishes a burning splint. Which gas is this? Carbon 4 oxide. So am I going to go to the inference and write carbon 4 oxide gas produced? No. At the inference, you do not give the identity of the gas. The inference should be the substance that produced the gas. So your inference is supposed to be carbonate or hydrogen carbonate ions present. Why? Because if you have a carbonate and a hydrogen carbonate on heating, in most cases they decompose, leading to the formation of carbon 4 oxide gas. Okay, what if you got a colorless gas that relights a glowing splint? This is oxygen gas. So what is your inference going to be? You need to mention an ion, remember. It's going to be nitrate ions are present. You find that the nitrate decompose on heating, releasing oxygen gas. So that means you have a nitrate present. What if you have a colorless, pungent smelling gas being released and this gas turns moist red litmus paper blue and has no effect on a blue litmus paper? Okay, let's pause there. When you're heating a solid for a question on inorganic chemistry, what you're supposed to do is, if you've been provided with litmus papers, you're supposed to moisten them, place them at the mouth of the test tube. Now, if a gas is produced, you should observe whether it has any effect on the moist litmus papers. Now, in the case of this, you're having a gas, number one, that is colorless, but has a pungent, smell, irritating smell, and it turns red litmus paper blue. My dear students, in our syllabus, there is no other basic gas apart from ammonia. So that means this gas that is being produced is ammonia. So what is your inference going to be? Ammonium ions are present. Now, if you get a brown gas that has a choking, irritating smell, that is no other than nitrogen 4 oxide. Now, this is going to be a gas that turns moist blue litmus paper red. Why? Because it's acidic. So how are you going to write your inference? Nitrate ions are present. Why? Because if you have a nitrate, the nitrate of moderately reactive metals decompose, leading to the formation of nitrogen 4 oxide and, as stated before, oxygen gas. Now, our last one with regards to the gases, if you get a colorless gas that turns blue litmus paper red, but has no effect on a moist red litmus paper, it remains red, then that gas is going to be an acidic gas. So you're actually going to write it as such, an acidic gas. Now, the reason why we are not specifying is because there are so many different acidic gases. We have nitrogen 4 oxide, as stated already. We have hydrogen chloride. We have carbon 4 oxide. In short, there are too many. So you just write acidic gas. Now, a point to note. You'll find that when you are told to heat a substance gently, they're probably only looking for water of crystallization. But if you're told to heat the substance strongly, then they're looking for the gases that are evolved and maybe the color of the residue. What about those that ask you to heat it gently and then strongly? Well, everything then. Now, moving on to our second preliminary test, and that is solubility in water. So this is whereby you are asked to take a portion of the solid, dissolve it in water, and so on. So you're supposed to note whether the solid dissolves or not. So the first observation, if the solid dissolves, so you're supposed to note that the solid dissolves to form a solution. So don't just stop at solid dissolves and you're done. No, continue to the next part and earn yourself a full mark. So the solid dissolves to form a colorless solution if the solution is colorless. So in this case, we have two inferences. Inference number one is tied to the solubility of the salt. So since the solid dissolved, that means that this is a soluble salt. Inference number two is tied to the colorless solution that is formed. Since the solution is colorless, that means that there are no colored ions. So are you going to go ahead and write that colored ions are absent? No. Specify. So you're going to write Kufefe is absent. Copper 2 ions, iron 2 ions, and iron 3 ions are absent. So if you include all 3 ions, you get yourself a full mark. If you just mention 2 out of these 3 ions, half a mark. What about if you just mention 1, maybe copper 2 ions are absent? You don't get any mark. And if you add any other ion apart from these 3, remember we talked about contradictory ions, then you will be penalized half a mark. Okay, now moving on. What if you get a solid dissolving, but it's forming a colored solution? Then you have to specify the color of the solution formed. For example, the solid dissolves to form a green solution. So here you're going to have 2 types of ions that could be present. You could have iron 2 ions or copper 2 ions being present. And of course, your second inference is that this is a soluble salt because it dissolved, right? Now, I want to mention this. There is an assumption that when it comes to the formation of a green solution, it has to be iron 2 ions only. You know, we tend to believe that copper 2 ions tend to be blue in color and so on, which is wrong because you find that some copper ions, for example, like those that are present in copper carbonate or in copper 2 chloride, are actually green in color. So either of these 2 could be present. If the solid dissolves to form a blue solution, then copper 2 ions are present. If it forms a brown solution, then again, this is a soluble salt, but iron 3 ions are present. What about if it doesn't dissolve at all? Then it's an insoluble salt. You're going to get a case whereby the solid partially dissolves and you are told that you're supposed to filter to obtain a filtrate and a residue. So in this case, how are you framing your observation? Simple. You're just going to write a colorless filtrate and white residue is obtained. Bas. Now, what is your inference? That the solid is a mixture of a soluble salt and an insoluble salt. Now, since a colorless filtrate and a white residue have been formed, that means kufefe are absent. Now, moving on to the next one, the physical appearance of the substance. So you're supposed to explain the state of the substance, the texture, you know, whether it's crystalline or is it in powdered form, and yes, the color. So this is whereby you can write whether you have white crystals, blue crystals, white powder, and so on. Now, our last one, flame tests. Now, flame tests are carried out when solutions of metals are exposed to a flame. So what happens is that they give off a characteristic flame color. This color can be used to identify the metals present. Now, I'm not going to go into detail regarding the flame test because this is something that I've already covered before. So if you want to learn more, be sure to check out this video. And that brings us to the end of the preliminary tests.